Sir, can you check my audio if it is fine?
Sagar sir, we'll wait for 5 more minutes, sir.
No problem, sir.
Okay.
Yeah.
Claimed by universities.
Sagar sir, shall we start, sir?
Yes, sir.
Sir, yesterday, one thing some participants said that sometimes the voice is somewhat low.
Okay.
Only that one told, sir. Some participants they messaged me that the voice is somewhat low, sir.
Fine, sir. I'll keep it
Okay.
check on it.
Yes, sir.
Yeah.
Yes, sir. You can continue, sir. Thank you.
Yeah. Thank you, sir. Good evening, all. Welcome back for the day 2 workshop on data science with Python. Just to remind all of you, the instructions is going to be same. If you have any questions, please feel free to post your questions on the chat window. I will keep monitoring all the questions that are coming in. I'll answer them at the appropriate time. If there are any questions that are left unanswered by the end of the session, I'll make sure we will have some 10 minutes dedicated to answer those questions. To start with today, this is going to be the agenda for day 2. To give a brief about what we have discussed yesterday. Yesterday, we started with introduction to data science. We spent time to understand what is typical data science looks like. So what type of applications that we want to build using data science. So data science is all about decision making by predicting things that are about to happen into the future. So the major part of data science is the predictive analytics. And within the predictive analytics part, we mainly focused on supervised learning because that's the biggest area within the predictive analytics. As a data scientist, we would have to master. Within supervised learning, we have two types, the regression and then the classification. In regression, we try to predict a outcome that is typically going to be a continuous number. In classification, we are going to predict a target variable that is generally discrete, binary. We saw an example for each one of them, predicting the resale price of a car and predicting the customers who are going to default their loans. Predicting the resale price of the car, guessing the resale price of the car is nothing but a regression problem. And predicting the customers who are going to default the loans they took from the bank is a classification problem, a binary classification problem, because our target variable here takes values like yes or no, 0, 1. Okay. And we discussed about the approach. What is our approach? We will always try to learn from the historical data. So we take a sample from the historical data. We will try to learn from the historical sample. And from that learning, we are going to make predictions into the future. And once, let's assume that we have learned and we have started making predictions. Now we want to judge how good our predictions are. So without assessing how good the predictions are, we cannot blindly trust, we cannot blindly rely on the learning that we had. So to assess that, we use some sort of metrics, performance metrics. We discussed about some metrics in regression. We discussed about some metrics in classification, right? So that's the basic level introduction to the data science. But to perform all these tasks, we need the help of a programming language. Many programming languages, like I mentioned yesterday, we can do this, we can perform these tasks with different programming languages. but Python is the most popular among all, and that's the
Sagar sir.
reason we chose Python.
Sagar sir,
Yes, sir.
some participants are telling that voice is too low, sir.
Okay,
You can
is
see
it,
in the chat box.
okay. Is it same for everyone?
Please type in the chat box. Maybe. For some people it is audible, sir. Maybe some people it is not audible.
Okay, please check your volume settings once, because from the mic side I did check. It's all fine. Maybe you try to increase your volume to the maximum extent. Okay, a lot of people saying voice is good and few people saying voice is not audible.
I request all the participants to use headphones or earphones.
Yes.
Then it will be audible.
Okay, so most of them are right now saying the voice is good. I will maintain the same pitch and the same level throughout my presentation.
Thank you, sir.
No problem, so thank you. Yep. Okay, so let's get into day 2. So we need a programming language to do all of this stuff. So we start the day 2 with introduction to Python. So the Python is going to be our go-to programming language for anything in data science. So let's start with how can we use Python. So today I want to set the basics of the usage of Python. How do we get started with Python as a programming language? That's going to be the main agenda. I may not be able to cover each and every aspect of it because of the limited time that we have. I'll try to point out some of those additional readings as in when we hit those steps. You can make a note of them. You probably would have access to this recording again, so you can listen to it again. So those are the additional things that you probably have to prepare for yourself, read for yourself. Okay. Now with that, let's dive into our day 2 session. First of all, installing Python. So installing Python can be done in many different ways. For any official information on Python, you can visit this python.org. So this is the official page for Python. So every news, everything, documentation, installation files, everything you will find in this python.org. Now, I'm not going to use this one here. So if you want to really download the Python, plain version of Python, you can simply click here. You can see the latest version of Python is 3.8. So people who are already familiar with Python, you might know that Python had 2 major versions. We call them as Python 2 and Python 3. So anything that starts with 2.7 is the Python 2 version of it. Anything that starts with 3 dot something is the Python 3 versions of it. Python 2 is almost deprecated. It's not going to be supported anymore. So we completely stopped using Python in the industry. So even if you are familiar with Python 2, now is the time that we have to move towards Python 3. Some syntactical changes would be there here and there between Python 2 and Python 3. But if you are starting to learn Python right now, always start with Python 3. Don't look into Python 2. That's very age-old one. Nobody is using it anymore. Now, if you download this exe file, and Python is platform agnostic. So you have it on Windows computer. So this is a Windows computer that I'm using. Same thing will work very well on a Mac or on a Linux machine. Generally, I prefer to have a Linux machine, but for all other convenience, because most of you might be using a Windows machine. So that's why I'm trying to show all of this stuff on a Windows machine. So you can download the Python exe file and you can install it. Wait a minute. Having said that, I'm not going to use this Python here. We are going to use a redistribution of it called as Anaconda, the bigger brother of Python. Now, why Anaconda? Why not Python? Anaconda also has the same Python behind the scenes. That's its engine. That's where the execution is going to happen. But to make it more user-friendly, Anaconda comes up with a very good IDE. We call this as interactive development environment. So for different programming languages, you might have seen different interactive development environments. For example, Java, you have Eclipse, you have Visual Studio, which can work with many different programming languages, be it C, C++, etc. So these IDEs make the interaction with the programming language and the development very easy. That's the reason I am choosing Anaconda. Second reason why we prefer to go with Anaconda rather than going with the plain version of Python. Python comes up with a lot of modules, packages. We will see those packages, some of them in a little while. And there is a whole bunch of such packages. Now, if you are thinking what is this module or what is this package, let me give you a simple layman example to understand the module or a package. In C++, I think most of you might be familiar with C++. That's why I'm quoting this example. Whenever you are about to write your program, at the beginning, the first line, we used to write hash include stdio.h, math.h, some things. Why are we writing those steps? So math.h, is nothing but a kind of package. It has a lot of functions pre-written into it. For example, if you want to use a sum function is maybe available already in math.h. You don't have to write the logic of how to sum numbers again. You can straight away use that function available in math.h, right? So that's a package. Package is a module, is a set of functions which will make the job of a developer much more easy. And we have a whole bunch of packages. I don't know the count of them. It could be definitely going into a few thousands. Now, when you have such a whole bunch of packages, trying to figure out what packages you need and installing these packages one by one is a very hefty task. When you install your Python, for example, if we go here and if we try to download this Python 3.8, and when we install it, it installs the very basic version of Python. It has a computation engine, that's all. But to get the capabilities of all the other built-in modules and third-party modules, we have to install those modules one by one. I'll show you how to do that as well in a little while. Okay. Now, Anaconda has brought in a package by combining all those modules that we commonly used as a data scientist. So that's why Anaconda is probably the most used tool for the data science teams across the industry, different companies, right? What they did is they packaged Python, they combined all the packages that typically data scientists use and created one single exe file. So you do not have to install a lot of these packages. These packages are pre-installed for us. So that makes our life much more easier. So two reasons why we choose Anaconda. One, it brings in a beautiful IDE, and we will see what that IDE is in a little while. Two, it also installs a lot of additional packages that we regularly use in the field of data science. So we don't have to install them one by one. I see some of the people raising their hand. Unfortunately, we cannot have a person-to-person interaction. If you have any question, please post a question on the chat window. I'll take a look at them and answer them for you. Thank you. Now, let's get started with this. So now when you click on Get Started, it gives you some product information, some latest news about all of this, etc., etc. You can look at a demo of Anaconda. You can read what is the latest in data science, all these things. What we are interested right now is installing Anaconda individual edition. So this individual edition is free of cost. You don't have to pay any licensing fee, even for the commercial usage. So that's good. Python is also open source programming language, and the repackaged version of it, the Anaconda, is also open source for us. Now, when you go here and click on the download button that you could see, it gives you the install files for different operating systems. So these are all the different operating systems. As I said, we have Python 2 and we have Python 3. These are the installation files of Python 2. Don't even touch them. Don't install them anymore, because the support has been taken out and the industry has been throwing this Python 2 away. So we do not want them. So these are the installation files that are built on Python 3 version. Now, depending on your system that you have, the laptop or the computer that you have, you probably want to choose between a 64-bit installer or a 32-bit installer. Most of the computers today are already 64-bit. I don't see any 32 bits anymore available in the market. Now, if you are very sure that it's a 64-bit, go ahead and by default go with 64-bit. If you are confident that it's not a 64-bit and it's a 32-bit, you can install it. No problem with 32 installation on a 64-bit system, but 64-bit installation on a 32 probably would throw some challenges. I don't know, it might. Okay. If you are using a Mac, an Apple laptop, you can you can take the file from here. If you are using a Linux version of the machine, like Ubuntu or RHEL, whatever versions of Linux, so you can take the installation file from here. Now, I'm going to click on this, and if we click on this, it would download this file. You can see here, it is going to download Anaconda 3 2020, some x8664.exe. It will take some time, and to avoid that, I have already downloaded it, and it's ready in my download section. So see here, the file is already ready, available with us. So let me go ahead and straight away install it. Installing is very simple. You just keep accepting the defaults, and it would be done in a few seconds. It doesn't take much time. right? Now, our installation is about to complete. Once we have this installation done, we have Python installed on our machine, and on top of the Python, a Anaconda, a IDE provided by Anaconda is also installed. Along with it, all the required packages, the modules that we use with data science, those are also going to get installed. Okay, and we can start using Python right away. If you look at some other tutorials, it might be slightly different. The reason is this is the new web page which has been recently launched by Anaconda. The older version was altogether different. So that's why you might see some sort of differences in the installation steps. And this is the latest one which we are picking from. Follow these steps, get the download, install it, and in a minute or two, we would be ready to use this. So meanwhile, as it is trying to take some time to install, let's briefly talk about some of the concepts in Python. So Python is called as a interpreter. Generally, when you look at any Python tutorials, most of them use a kind of shell command line prompt to show their execution steps. And yes, that will also work. But if you want to know more about Anaconda, you can fill up this form and you would get to see some PDFs sent to your email, which is very informative for a beginner. If you are not familiar with Anaconda before, I would strongly recommend. Now, the installation part is done, and if you go here, Anaconda 364-bit is installed, and under this Anaconda 3, you see a lot of different applications. The one that you must be interested is this Anaconda Navigator here. So click on this Anaconda Navigator. It would throw up a kind of user interface in a minute. Yeah, so this is the user interface that you typically see when you go to the Anaconda Navigator. I'm repeating this step. You go to Anaconda 3 here. Under this, you see a lot of different files. What you are interested is this in this Anaconda Navigator. Now, you see a lot of them here. You see Jupyter Lab, Jupyter Notebook, you see PyCharm, Jupyter Lab, Jupyter Notebook, PyCharm, Spider. These four are the popular IDEs typically used by developers of Python. Some of them use PyCharm, some of them use Jupyter Notebooks, few of the people like Spider. Of all these four, the most user-friendly one is the Jupyter Notebook. So whenever you are beginning to use Python for the first time, I strongly recommend you to start with Jupyter Notebooks. Then once you are comfortable, you can choose between a PyCharm or some other user interface, some other IDE. The most simplest of all of them is the Jupyter Notebook. So that's why I'm going to start with Jupyter Notebook. And Jupyter Notebooks are very popular among data scientists, and most of them use this Jupyter Notebook. A Jupyter Notebook simply uses a a browser. In this case, it is using a Internet Explorer to create a to show you a IDE, the development environment. These are all my directories available in the C drive. So you pick a project directory. You can pick any project directory. Let's say I pick my project directory as this PyCharm projects, and these are the subdirectories that I have: AI, ML, DSML, Python. When you do this for the first time, you might not have any of these on your machine. So whatever the directories that are available on the machine, you would only be able to see them. Now let's say I pick this one, and in this one you could see some files already present, like 1_introduction to python.ipynb and 2_introduction to pandas.ipynb, some of the files, and a additional file that you see here as titanic.csv. So this is the environment where you try to put all your files. Now, how can we do it? You can see a new button here. Click on this, and what type of file you want to create? Do you want to create a folder? Do you want to create a text file? Do you want to create a Python 3 file? So let's say we click on the Python 3 file. So it has created a file, and this file is currently not named. So that's why you see untitled here. So let's say we will change the name of the file. Let's say workshop_code. You can give whatever the name that you want. Generally, I would recommend not to use spaces in the names. You probably can use underscore instead of spaces. So that's a programming standard that we typically follow. Okay, so I gave a name to this, workshop_code, and let me explain all of these features over here. Once we created a workshop_code, you can see a kind of box over here. We call this as shell. This is where we are going to write our programs. Let's say we write our sample program like this: a is equal to 10. That's a line of code in Python. What this line of code does is creates a variable called a and assigns a value 10 to it. That's how simple Python is. And if you have seen that video that I have shared, introduction to Python already, you probably would not have any difficulty in understanding this step. In that video, I think PyCharm was used, but here we are going to use notebooks. So that's why my objective here is not to go into the code right away, to explain the features of notebook. A notebook will always have an extension of ipynb. A typical Python code will have an extension of .py. So a difference between a Python code, simple Python code, and a notebook is in this extension. So notebooks will have an extension of ipynb, and Python codes will have an extension of just py. Now, let's say we want to add one more shell to it. We would like to write the code in bits and pieces, and we put those bits and pieces into smaller blocks. Let's say we write another line over here, and c is equal to a plus p. So this is a block of code which is almost completed here. Now we would want to add more lines to this code. So we would do that in the next shell. So whenever you click on this plus sign here, you would create a new shell. And this is where we are going to type our code. Sometimes the good thing about notebooks is notebooks will have code and some description about the code. You can call those as kind of comments, output, all of them in one single place. So that's the beauty about notebook. Now I'll complete this notebook. It's just like a web page. Now if I ship this notebook to anyone, I mean if I send it as an attachment in the mail, if they open this in a Internet Explorer, something like this, they would be able to see my code, see the output that I have generated out of the code, everything without executing the code. Let's say now I am going to print the value of C here after performing those steps. I'm executing this. You can execute it by clicking the run button. This shell was highlighted. Now when you click on this run button, the code in this shell will be executed. These ones will be untouched. We can run this with the help of the run button over here. The keyboard shortcut is Control Enter. You can use Control Enter or you can use Shift Enter. One of these two, Control Enter or Shift Enter. So when we highlight a shell and hit Control Enter, the code is executed. The block, whatever the code that is there in the block, it would get executed. Yeah, anyone posting some questions? I see people raising some of them. Oh, okay, I think I missed some of the questions. Let me answer them. Why Python 3.x is not supported to Anaconda? Maybe they haven't built the files. They have to look at the package module availabilities as well. Very soon they might launch the newer version of Anaconda with Python 3.8. As of now, it has 3.7. 3.7 is still the stable version. Yes, 3.8 is still, they call this as a beta release. There might be some bugs and some improvements. Once it is thoroughly tested, and if they think that it's perfectly stable, Anaconda will pick it up and try to build their Anaconda distribution using Python 3.8. Okay. Maybe Anaconda is waiting for Python 3.8 stability, or some of the modules that Anaconda is using were built for Python 3.7. Those modules are not yet available for Python 3.8. So if they have to release a version with Python 3.8, first those modules has to be rebuilt for Python 3.8 so that they can be packaged together. Okay. Now, you don't have to really worry about those subtle differences in the versions 3.7, 3.8. I hardly see difference working on any project when we use 3.6 or 3.7. Maybe those differences are not noticeable at all unless you go to the documentation and see what is the difference between Python 3.6 and Python 3.7. You would probably not come across that. So I don't really pay a lot of attention to those minute differences of the versions over there. As long as it does the job for us, we would keep sticking to Python, let's say 3.6 itself. We have a production environment that we use in our office, and we have 3.6 running on it for almost like more than a 6 months by now. And we did not see any need to update it to 3.7 or 3.8 for that matter. Why? It's unless you have a problem with a bug, or unless you have some features that you want to use which is available only in 3.7, there is no need to go ahead and update it. We can use Google Colab for sure, yes. To start with, Google Colab is definitely a good thing to start with. The limitation is Google Colab gives you limited resources because it's just for practice. It's free of cost, right? So you get to have some limited resources. Am I audible to all of you? Okay, good. Fine. Okay. Yeah, if you want to use Google Colab, yes, you can try with Google Colab. But if you have a system, you have a laptop, or you have a desktop, you could very much install all of this so that you get more hands-on on what modules are required. You can install those modules and you can try to use the modules on your own. So coming back to the Jupyter Notebook intro, so this is how we can add shells. Let's say now we want to add a new piece of code here. That is p is equal to a 2.14 something. Now, if we run this, it gets executed. So 2.14 is added to p. If you do not want this block to be present, if you think this block is not useful, you can just go ahead and delete it. So when you cut it, the block is automatically deleted. Unless you want to paste it further down, it's just like assume that the block is kind of deleted. Okay, then new is equal to 10.5 something. You want to move this block of code up. That means this one should be at the beginning. So if you select the block and click this up arrow mark, now this block has been moved up. If you want to move it down by one step at a time, you can click on the down arrow mark. This button here is a stop button. Now, sometimes when you write a block of code, for example, think that you have built a function, you have written your own function, and you execute the function. It takes a lot of input data. So the execution might take, let's say, 10 minutes. Now, after a few minutes, you realize that there is a problem in the function and there is no point executing that function anymore. You want to stop the execution. You can just go ahead and click on this stop button. Now, this piece of code, which was under execution, would stop right away. Okay, so that's a useful feature to interrupt the execution. Now, this piece of code is under execution. When you click the run, now it just takes a blink of an eye to execute this block of code. So that's why you probably would not see the difference. When we go to some other examples later, you would see the execution phase. Now, if you want to interrupt the execution phase, we can click on this. So this is a kind of refresh button. If you want to restart the kernel, sometimes we want to restart the kernel. Different situations where we want to restart the kernel. We we want a package that is not installed along with Anaconda. Now we go ahead and try to install that package. Now when we install that package, we want to use the package, but that package is not available right away because we installed it, but this session of Python has started before the installation of it. Now to make use of that package, we have to restart this session of the Python. So we can go here and try to click on the restart button. Okay. Yeah, audio is working fine for most of them. Okay, thank you. Finally, you have been able to hear. Good. Okay. And if you want to run the entire kernel at one go, completely rerunning it, let's say we built a different blocks of code, 10, 15 of them. We want to run all of them at one go. You can click on this. Now, let's say I want to give some instructions here. So people who are reading this code later, they understand what this code is going to do. So this is a introduction to Jupyter Notebooks, Python 3.7 is used. Now, for today's class, we are going to look at pandas and data visualization. So this is something to tell what this particular code is doing. In a lot of other programming languages, we kind of give this instruction by commenting these lines out. So if we put a hash symbol before the line, then it becomes a comment. So this is how we typically used to give instructions for people who are trying to read this program to understand what this program does. But a notebook has other features that we can use. Now, this is actually not a code. This is just a text part of it. Now, we can go back here and change this to markdown. Now, once you convert this block into a markdown, it knows that this is not a piece of code to execute. This is just a text input, and it tries to show this in a markdown form. Think of this as a kind of a simple heading on a web browser, and it clearly shows that, okay, this is an introduction to Jupyter Notebooks. Python 3 is used. What is being programmed here? We are going to see some programming on pandas and visualization, right? So in a notebook, you have a kind of documentation present in it like this. You have the piece of code, and then you have the output. When this piece of code is executed, what is the output this piece of code has generated? You can see it here itself. So all of them in a simple web browser based UI. Your web browser can be a Google Chrome, it can be an Internet Explorer, or it can be a Firefox, doesn't really matter, right? So you get to see the building of the code, the comments and the documentation of it, and the output of the code in one place. And that's the reason I always prefer to go with Jupyter Notebooks rather than the other UIs that we have seen here. A lot of developers may not be data scientists, but developers of software, other applications, most of them like PyCharm a lot because PyCharm is somewhat closer to Visual Studio. That's why some of them like PyCharm. Personally, I am more interested in using Jupyter Notebook or Jupyter Lab. They look similar, but don't start with Jupyter Lab, but stick to Jupyter Notebook. And this is how a Jupyter Notebook would look like. Okay, looks like this. Let me take a pause. Any questions here so far? Clear with how we can use Jupyter Notebook? Good. Now, talking about the modules. In Python, we have a lot of modules. And if we have to use a module, we have to first import that module. For example, import pandas as PD. So pandas is the module name and PD is an alias that we are giving. So this is a very common step of importing modules. Now, how do I know what modules are there and what modules to use? So this comes with experience. That's where you would have to learn a lot of Python programming. To begin with, as a data scientist, the most important modules that you would probably have to learn is this. Make a note of this list. I would not be able to cover all of this for you, but you can prepare, you can read about these modules by looking at small tutorials by yourself. But in the field of data science, these are the important basic modules of Python. The first one is called numpy, numerical Python. It has a lot of good functions, how to handle numerical data, everything built into it. So numpy is the most important package for us. Next is pandas. In short, this is panel data. So it's simply called as pandas as a package name. So pandas will help you to manipulate and manage the data, like getting data from a flat file. We will see that in a while. Trying to look at how that data looks like, creating new columns in it, deleting some of the existing columns. So that's called as data manipulation. Data manipulation and data analysis is mainly done through pandas. So that's why pandas is another very important library, module for the data science work. The third one is SciPy, which is scientific Python. A lot of functions are already built into it. We may not use SciPy directly, but in future, we are going to use more advanced modules. For those modules, behind the scenes, SciPy plays a significant role. So you don't have to go on and try learn SciPy, no, not required, but at least at a high level, what type of functions exist in SciPy is good to know. And for data visualizations, we use matplotlib and seaborn. So these are the packages that we use if we have to build any type of data visualizations. And finally, our secret weapon, the magic wand in the hand of a data scientist, we call it as scikit-learn. in short, scalar, right? So these 5 modules of Python are the most important ones for a data scientist. And I'm not saying this these 5 are the only ones. It's not limited to these 5, but these 5 are the most essential modules that we have to learn as a data scientist. Now, when we want to use pandas, so we have to first import it. Import pandas as PD, import numpy as NP. So these PD and NP are the aliases. Now we can give any alias here. Instead of PD, I can give PN. Instead of NP, I can give NM. But the standard used in the industry for pandas, it's PD, and for numpy, it's NP. So we would always stick to the same standard. So anyone who is reading the code later doesn't have to get confused. Hey, what is PN? Where is this PN coming from? So the standard aliases exist for most of these modules and packages, especially for these two, import pandas as PD and import numpy as NP. Okay. Any questions so far? Let's see if we have any questions. Which one you want me to repeat? 7 here is the execution sequence. Okay, now this is this is not a code, so this is a markdown. So I'm going to change this to markdown. So now it doesn't look like a code, it just looks like a simple text over here. And anybody who reads this, who visits this IPy notebook, then they know that, okay, these are the packages that we are going to use in this particular notebook. And this one here, let me execute it. So when it was under execution, for a brief while, you could have seen a star in this place. And after that, it changes to a number. Now that number is the sequence of execution. Now let me restart my kernel. Okay, 1 second. Now this is the non-code block, the markdown block. Let me execute this. You saw a star for a brief time period, and then it changed to 1. So that 1 is the sequence of execution. Now, if we click on this, now this one is given 2. And if we click this, this is given 3. Now, just in case at some point in time, you execute this again, it changes to 4. Now you can notice, okay, this is 1, this is 3, this is 4. That means this block of code is executed after this block of code. And if that's a problem for us, we would probably have to go back and execute this entire code if you want that to be in sequential order. Okay, just a minute, sorry. Sorry for the interruption. So numpy is actually a package. It's called numerical Python. It has a lot of built-in functions, like how to handle numeric data, and some sort of numerical manipulations are built into it. So numpy is nothing but a simple package we are going to use as part of this code. In a little while you would see, but to use any of the functions that are available in numpy, first we have to import that. And this is the packages that I was talking about. These packages are installed when we did installation of Anaconda. Now, there could be some of the packages which are not yet installed. Now, when we try to run them, for example, I run this step. When I run this, it throws an error, no module named text blob found. So text blob is another module, but we haven't installed it yet. So that is why it is throwing an error. Hey, you do not have a module called text blob installed on your Anaconda. Now, whatever the functions that are available in this text blob, I'll not be able to make use of it. Now we need to install it. Now to install it, you can go here and click on the Anaconda prompt, the shell. So there are two ways to install. You can say conda install. What is the name of the package? You can call it as text blob. Now it reaches a external repository. You need to have an active internet connection for this. So if you do not have an active internet connection, this will not work. Now from there, it will try to find out the package called text blob, and it will try to install. If the package is found, it says the package is not found. So because it might not be available in the repository called conda. So another popular repository to install packages along with Python is pip. So pip install textblob. Now, if pip has it, then it has successfully installed the text blob. Version is 0.15. So we have got this package installed. Now the package is just installed. I can use it right now. Now if you say import text blob, there is no issue. But when we do not have that package installed, it was throwing the error. Okay, so these two packages, numpy and pandas, will help us in manipulating the data, and that's the reason in this module, in this session, we are going to stick to mostly numpy and pandas only. So when you are importing, we are giving an alias to it. The alias will make our further code easy. Let's say I probably want to add a new block of code here. I would say some k is equal to np dot random dot rand of 3. Now there should be some value in k. Now it says it created k. K is an array and it has 3 values in it. Now how did we create this? Where did this output came from? First, we have used a function called random, which is part of the module numpy, np dot random. So this is a function, and this function is written in numpy. So now you can simply write numpy dot random dot rand and create 3 elements using this function. Randomly create 3 elements using this function. So that way we can do. Now this will also work, but we have already given a alias to numpy as np, so you cannot use numpy anymore. So instead of numpy, we would always give np dot random dot rand, and these are the hierarchy. So random might have a lot of functions, and within that rand is one function, and if you want to generate some numbers randomly just to play with it, you don't have to explicitly try to find that. You can randomly create those numbers using these type of functions, right? Now this is the module name, this is the submodule, and this is the function available in this module. So that's the hierarchy that you typically see in functions that are available in Python. Okay. Let's see how we can start some simple programming. I think most of you might not have seen that video because all of this could have been much easier. So let's start with it. I'll briefly spend some 10-15 minutes on the Python programming, but then I want to jump into pandas and spend more time over there. Fine. A variable in Python can be simply created like this. Now, if we say a is equal to 10, we have created a variable and it has a value of 10 in it. And if you want to print it, you can simply say print of a, and it would print the value in it. Now, compare this with other programming languages. In other programming languages, if you have to define a variable, first you have to give what would be the data type of that variable. You have to explicitly say that integer a, float a, character a. So that's how you typically try to create them. But in Python is a very user friendly because you do not have to do all of these steps. Python mostly take care of these steps for you. Now, if you say type of a, look at when we simply say a is equal to 10, I did not explicitly say what should be the value in it, what should be the data type of it. The moment it sees number without any decimal place, Python automatically creates this variable as an integer. Now, a is an integer. Same, we are overriding a will be deleted and recreated in this step. Now 10.5 and print a and print type of a. I want to print both of them, right? So a will be printed first. A is 10.5, and what is the type of a? Type of a now is float. In the first case, when we give a is equal to 10, a variable a is created as an integer. In the second case, when we give a is equal to 10.5, it is created with a type of float. So that means Python is doing the job of figuring out what is the right data type for a given data and creating it appropriately. Now a is equal to, within quotes, data science. Now the moment we give something in quotes, it would be treated as a string, as character data. Now print a and type of a. So it prints data science for you, and then it is in the form of a string. The type is a string here. Let's create one more. A is equal to capital T RUE. Now print a. You can write print statement, or you can simply put a and then you put type of a. Okay. Without, there will be always one explicit print if we don't write this. Now it has a value of true, and look at the data type of it. It is a Boolean. It's not a string anymore. So capital TRUE will be treated as Boolean 1, and capital starting F with caps false will be treated as 0. So these are couple of exceptions. So when you see something with capital TRUE, it means that we are actually creating a Boolean variable, which is like ones or zeros. Okay. The common data types that we typically see in any programming language: integer, float, string, and then Boolean value. Of course, we have complex numbers also, but in the world of data science, we don't worry about complex numbers, so we don't we don't see much of that. Maybe in some exercises you might come across, but personally, I haven't used complex numbers a lot, but they do exist. Here, when we are adding a print statement to it, it is trying to create the output of this and try to show something like class float. But that's just because of the print statement there. Without a print statement, if you simply type of A, it would be printed as a float. Like that class has nothing to do with the typical class that you see in the object-oriented programming. Yes, we have object-oriented programming here also in Python, but that would be a very, very far away step, because you are still at the beginning level. We would probably don't want to get into those concepts, that is advanced concepts of a programming language here. Okay. Good. Now, there are other built-in data types in Python which are very, very important. And unfortunately, I'll not be able to spend time on all of them. I'll probably spend time on a couple of them. You would have to read about them. So the most popular data types in Python, one is lists, then tuple, set, dictionary. So if we have to effectively use Python programming, the power of Python programming comes in when you learn all these type of built-in data types available in Python. Okay. So for example, how do you make a list of it? You can try to read about this on your own. It's not code, it's actually a markdown. You can read about all of this on your own. Now, let's say we create a list. A list is generally created like this: 10, 20, 30, 40. So why these data types are very good? You probably don't need any data structure management if you learn these data types. For example, in another programming language, if you have to store a set of values into one single variable A, you probably have to define A as an array and put elements into the array one by one. That's bit complex there. But here, just using a square brackets and commas in between the data, I created A. Now, if we simply say A, it would print all the 4 values for you. We can access those elements like how you access an array. A 0 would print you the first element. A 1 will print you the second element. You can also use sequencing. So when you see a colon operator in Python anywhere, treat the colon operator as a kind of sequencing. You do not have to write it explicitly. Now, if you use this sequencing 1, 2, 3, it would print 2 elements for you. Element number 1 element number 1 is 20, element number 2, element number 2 is 30, and 3 won't be printed. In Python, when you use sequence, the last one here is excluded. So it's virtually up to 2, third element will not be printed. So when we wrote 0 to 3, first 3 elements will be printed, 10, 20, and 30. So this one is actually exclusion. So that's another exception that we have to remember. Now, the built-in data types like list, etc., has a lot of modules available on it. Now, if we say a dot, now this is a good part of Jupyter notebooks. Whenever we are trying to write code, we can get the help by using the tab button. Now, this is an object that I have created. And what is the type of a? You look at the type. Yeah, it should be a list. Yes, it is a list. Now, on this list, we can have some sort of functions applied on it. Now, what are the functions that are available? What are the modules that are available? So if you simply hit a tab, it gives you all the functions that are available for this particular object list that we have created. Now, append is a function that is available. Now, let's say append 50. Now, let's see what happens if we do this. After this step, if we say a, this function append, a.append, has appended this element to a list with a. So that's how those functions, available functions on these lists, make our job easy. If you are familiar with data structures, you probably would realize how easy it is to do all these functions or to all these operations with the help of built-in functions that are built-in modules that are already available on the list. Now, when we say a.pop, now pop is a function which would take the last element. So if it is like last in, first out, in a data structure, you want to take the last element, you would simply say a.pop. So it would take the last element out. Now, if we try to do a.pop again, so it would take the last element in the order. So 40 will be removed and it would be thrown out, right? So this is how inserting an element, accessing elements, adding elements, deleting elements, which will be very easy with this type of data types that are available. Okay, and that's why you have to read about this one. So these are very, very powerful ones. So if you have to be strong in Python programming, the first things that you need to do is learn about these data types that are available in Python, what they are capable of, where to use them. So that's going to be a reading material for you. So I have showed some simple examples of what a list can do. You have to definitely learn a lot of them. So 31 is gone when, for example, right now, if I try to run this again, it was 32, but it is 35 now, because this step is already executed. In the sequence, the next step execution is 35. So it has changed to 35. So that's why some of the numbers you might not see. Why I'm creating so many blocks of codes is to make it readable. Now, each line and the output generated by the line is print next to it. Most of you you people are beginners to Python. Now, when you look at each code of line, there is only one single sentence in each block, and you know what that line of code does and what is the output that it has generated. So to make that more easier, I'm writing only one line of code in each of this. But generally, when we start a project, we try to put 5-6 lines or a bunch of code that is performing a single task in one single block. We will see that in a while. Okay. To improve the readability, I'm just trying to make it easier for people. Now, when I send this notebook to someone else, they just look at each line of code and what is the output that it has generated, and it's easy for them to understand. Okay. Okay, let's now jump into pandas, our favorite. Now, in pandas, you have one, okay, another data types is when we go to numpy. In numpy, we have a numpy array, and we have a numpy nd array. So these are another data types that is part of your numpy package. The numpy arrays are very similar to arrays in any other programming language that you might have seen. So this is a one-dimensional array, and nd array is a n-dimensional array. Maybe we would see a couple of them in a short while, but as part of numpy, we can try to use them as arrays. Okay, now let's see, how do we create an array? I want to use some of the functions here. Now let's say a is equal to np dot random, which I have used dot I'm going to use a random function to create a numpy array. So let's say I want to create a numpy array with 4 elements in it. Now if we try to print the a is an array and it has 4 elements on it, and these are the 4 elements. One more trick, one more user-friendly trick. When you want to know what a particular function is going to do, generally, if you haven't used this random.rand function, you would probably not realize what this function does. And if you want to know, you go search on the internet, or you go to the documentation of numpy searching for it. But using the notebooks, you can get help from the built-in documentation. Sorry. So if you want to know what this particular function does, on the keyboard, you have to press Shift and Tab at the same time. Note it down. So if you press Shift and Tab, it will give you the inbuilt documentation, and you can see the documentation here. So expand it, there is a plus sign, you can expand it, and you would be able to know what is the documentation trying to say and how to use it. There would be a couple of examples also. Okay, now this is always going to give you values between 0 and 1 with a uniform distribution, and that is why this function random will give you a values between 0 and 1. You would never get 1, you would get 0 between 0 and 1. and depending upon the dimensions that you are asking for. If you want 4 values, it would give you 4 values. If you want 4 rows and 2 columns, now you are creating a 2-dimensional NumPy array. So it would create an array with 4 rows. So row 1, row 2, row 3, row 4, and 2 columns, and column 0 and column 1. In Python, indexing means the positions always starts from 0. So this is position 0, 1, 2, 3. This is position 0, column 0, and this is column 1. Okay, so that's how the NumPy arrays or ND arrays work. And now you can ask, okay, what is the advantage of going with NumPy arrays? The name itself says it's numerical Python. Sometimes when we have to deal with matrices, which is definitely the case, now a lot of those functions, like how to do matrix addition, how to do matrix multiplication, I'm sure in another programming language we would have definitely struggled, especially matrix multiplication is not so easy. So as part of NumPy, we have a lot of built-in functions which could do matrix multiplication just like that, and it's very fast as well. So that is where we would probably use NumPy arrays or NumPy n-dimensional arrays rather than using lists or some other data types that we have seen. So that's the advantage of going with the NumPy arrays. NumPy arrays, you do not have to jump into right away because NumPy programming is a little strong compared to pandas and other. I would request all of you to first get familiar with pandas. Once you are familiar with pandas, then you probably go with NumPy. And in pandas, we have again 2 data types, are the way how pandas tries to handle the data. One is called as a series, and 2, it is data frame. There was a question on when can we use RDBMS with this. Absolutely yes. We have to use a package. Let's say I haven't installed that package, but I'm just going to show you how to do it. Import cx oracle. So this is a package as some alias name. I can give this as cxo. Now this package cx oracle has some built-in modules and built-in functions that can help us to make a connection with a Oracle-based database. It can be Oracle 11g or something, right? So that's how you can try to establish a connection with an external database from your Python session. But here today, we are simply going to use flat files to get data into Python rather than having a connection with an external database. Pretty much alone, but I do not have a database accessible from this to show you that connection. So that's the reason I'm going to simply show you how to do it with the help of files. But here we have 2 more data structures, you can call them, that is a pandas series and a pandas data frame. Now this is where we would spend a lot of time, and this is where we have to learn a lot. Now let's see how we can create a pandas data frame. So pandas series is a 1-dimensional kind of equivalent to array in NumPy, and data frame is a 2-dimensional one. So this is a equivalent of table in your RDBMS. Okay, And most of the time when we try to handle data, our data would be in a two-dimensional shape. It would look like a table. And that's the reason, as part of your data analysis, you could be data analyst, you could be a data engineer, or you could be a data scientist. The most commonly used data structure that you would probably deal with is going to be a data frame. That's the reason we have to spend a lot of time understanding data frame. Okay, now how can we create a data frame? So let's say I'm going to create a data frame. This is a name that I am giving to my data frame. Now it can be any name. I'm just giving my name as DF. We have some valid naming conventions that we have to follow. Generally, it has to start with an alphabet, no numbers, and it can be followed up by numbers, alphabets, and special characters like underscore. We don't use underscores at the beginning or underscores at the end, because underscore at the beginning and underscore at the end are typically used with some system methods that are already built into Python. So we do not want to confuse the developers between a system built one versus a user built one. So we always starts with an alphabet. We can use underscore like this in between, but not at the beginning, not at the end. This is also a valid name. You can say underscore df. So this is also a valid name in Python, but as a programming standard, we would always try to avoid it so that we don't confuse people, like whether it is a created one by the developer or it is a built-in one. Okay, pd dot. Now, what are the functions that are available? Let's say data did we not execute this step? Why? Oh. A. Data frame. Now we have created a data frame from A, and let's look at how data frame A would look like. So this is a data frame. The difference between a numpy array is it is just arranged in the form of a nested list. So think of this as a list, this as a list, this as another list. But when it comes to data frame, it has a proper structure. So these are rows for us and these are columns for us. And because we did not give any column names, we don't have column names, and these are column indexes. And the column indexes starts with 0 and 1. We can give column names. We can give column names like df dot, okay, df underscore 1 dot columns is equal to, let's say I'll call this as column 1 and column 2. So these are the names that I am giving as column names for this df1. Now, if you try to print df1 underscore 1, then it would be having new names. So column 1 and column 2. This is like when we created it, we don't have column names, but when we give these column names explicitly, the column names are created. df underscore 2 is equal to df underscore 1, and in that I'm going to select only column 1. Now this is called as slicing. We would spend a lot of time on slicing, but if you want to select only one column out of a data frame, so treat this as a table, and you want to select only the column 1 out of this table, so you can simply say df1, and within this you can, within the quotes, you give the name of this. Now df2 will be created. Now what is df underscore 2? df underscore 2 will have only one column, and that is this column. And what would be the data type of it? So type of df underscore 2, it's a series. When it is one dimensional, pandas treats them as series. When it is two dimensional, when you have more than one column in it, it would be treated as a data frame. So in pandas, we have two structures. One is the series, one dimensional one, and the other one is data frame, the two dimensional one. We don't generally create data frames like this. Why would we create data? We are going to analyze the data. When we want to analyze the data has to come from some external place. Slicing horizontally, we would do in a while. Okay, in numpy, we cannot give column names. It just exists as a n-dimensional array. So this is how it would look like. But when we are doing data analysis, we want to have column names. Think of a table without column names. How could you handle it, right? So numpy arrays are meant for a different purpose. That's exactly the example that I gave. If you have a matrix, matrix doesn't have column names. There are two matrices and you want to multiply them quickly. That can be easily done with numpy. But if you want to have a table with columns, column names, so that you understand what each column is, what each column does, you need to have a structure which is very similar to a database table. And that's where we get to the pandas data frame. Now, I'm going to import some data into my Python from an external file. So you look at a file here. I have a file called titanic.csv. I can upload few more files to it. Let's say I have one more file called mpg. Upload this. I want to upload one more file, empty cars. Upload this. Now I have three files here. These are CSV files. Now, what are CSV files? If you want to take a look at one of the CSV files, I can show that. CSV stands for comma separated version file. So this is how the file looks like. CSV files are also called as the flat files. In a flat file, generally the data will be separated using commas. So see here, you have a comma between each of the data elements. So comma separated version file means the data is separated using a comma. And the first line here has column names like manufacturer, model, displacement, year, cylinder, transmission type, right? This looks very similar to a automobile data, and this is an automobile data. So these are the column names, and this is the data. From second row, the data starts. So now we want to read this data into Python and create a data frame out of it. Let's see how we can do that. My df, I am naming it as my df. You can give whatever the name that you want to. Yes, though I am using a comma separated version file, you can read the data with a file with extension .txt, .tsv, tab separated version file. In comma separated version file, the delimiter, the data is by default separated by a comma. In a tab separated file, it would always be a tab. In some other file, somebody might have created a different delimiter. So when you look at the file, you would come to know what is the separator. If comma is a separator, we would read the data by using comma as a delimiter. If in place of comma, if you have a tab, then we could read the data as using tab as a separator. PD dot read underscore CSV. Though the name says read underscore CSV, using this function, we can read the data from any type of flat file. Now, again, I don't know what read underscore CSV function does. I want to take the help of Jupyter Notebook. When you hit shift and tab at the same time, it is going to throw you the help. What are the arguments that this function read underscore CSV is going to take? The file path. Where is the file? The file is in this working directory. So I can simply say, what is the name of the file? I want to read this file, titanic.csv. So the name of the file is titanic.csv, comma, again shift tab. What is the separator? Data separator. Data separator is by default comma, and in our data it is a comma, so we don't have to explicitly say that. Header, do we have header in the first row? I'm not sure, so let's look at the yes, header is nothing but first row has column names, so we have header, so we need to leave it also. If we have if we don't have header, then we could change the argument as header is equal to false. Now we have header, so we would leave all of this. Now just other arguments are self-intuitive when you try to read about it. Now we have created a data frame called mydf by reading the file from an external file, by reading the data from an external file. Now let's see what we have in mydf. Mydf.shape. So this is a function which will tell you how many rows are there and how many columns are there in my data frame. Printing data frames is not advisable. Why? Sometimes your data files might have thousands of rows or even lakhs of rows. So trying to print them doesn't make any sense. So first you need to look at the size of your data frame. To know the size of your data frame, you simply say mydf.shape. So it will print you the number of rows and the number of columns it has. If you want to have a brief look at the data, how does the data look like? Now you can say mydf.head, a function which will print few records, first few records. If you want to print a specific set of records, I want to print first two records. So it has printed the first two records now. Look at, this is the index, row index. Row index starts from 0, 1, so on. So don't worry about this. These are the columns that we have. Passenger ID. So this data set is about the Titanic disaster. The information of the passengers who were there on the ship on that ill-fated night. Let's try to understand what happened. Who are the people? How many of them perished in that accident? And who are they? Etc. Right? Some sort of data analysis to understand this data. We will read one more file. We can do a lot of data analysis and we can understand the data by doing some data analysis on top of it. Survived. Now this is a column which takes values like 0 and 1. If the survived column says 1, that means that passenger has survived. If the survived column says 0, the passenger is not survived. passenger class, what class they have traveled, first class, second class, third class, name of the passenger, gender of the passenger, age. So some information that we have about the passengers over there. Fine, good. So this is the data that we have. We have 891 rows, 12 columns, and this is the data about the Titanic. Now let's read one more file. My df2 is equal to pd.read underscore csv, and in this I am going to read the file mpg.csv. Now, because this file mpg.csv is present in the same directory mpg.csv capital, Python is case sensitive. Anywhere capital letters and small letters would be treated differently, so you have to exactly write it in the proper case. Okay, so mpg.csv, and we would read this. We created one more data frame, and by default header is equal to true because I know that we have column names there, and data separator is a comma because this is a CSV file, so we have the comma as it is. Okay, now let's see how many records we have in my df2. My df2.shape, so it has 234 records and 11 columns. Let's see some data. df2 dot head. Let's print a couple of records. So this is the index, 0th row, first row. These are the columns: manufacturer, model, displacement, year, number of cylinders, etc. So this is a data that is about cars, so we know. Okay, fine. So we got the data into Python. Now starts the data management. Now I want to slice few rows. For example, let's say my df3, sorry, my df3 is equal to, or I'll call this as mpg2 is equal to my df2. So you have seen how we have sliced the list by using the indexes. We can do the same over here, but a data frame is two-dimensional. So we have to explicitly say what we are slicing. Are we slicing the rows? Are we slicing the columns? Before the comma, it is slicing the rows. After the comma, it means it's slicing the columns. Now, let's say we give 0 to 10 and nothing after the comma, and let's see what output that we get. My df2, okay, this is not allowed, it has to be. So using this iLocation, so iLocation will help you to slice the data frame by looking at the positions. Now, what is the output of this mpg2.shape? Look how many rows we got. We got 10 rows. Why? We are slicing the first 10 rows. So that's why we got the first 10 rows in the output. And we did not mention anything about the columns. So by default, all the columns we got in the output. Now, mpg3 is equal to my df2.ilog. Let's say we want to select first 25 rows and column number 2 to column number 6. Now let's look at what mpg3 has. mpg3.shape. Now it has got 4 columns and the first 25 rows. So the first 25 rows is there, and then we have got only the 4 columns. Column number 2, 3, 4, 5. Column number 6 is not selected. Let's see what are the columns we have. My df2 dot columns. So this will print the columns that are available in a given data frame. So the columns are manufacturer, index 0, index 1, index 2, index 3, index 4, 5, 6, 7, 8, 9, 10. That's how our columns are. Now let me print the columns that we have got in mpg3 dot columns. What we got? Column number with index 2, with index 3, with index 4, and with index 5. No 6 is not included. Though we give 2 to 6, always remember Python, the last one is excluded. Okay. So this is slicing based on the column positions or the row positions. We can do slicing based on names also. Now, how can we do based on names? So mpg4 is equal to my df2, and then we want to select the columns with the name here and cyl comma class. Okay, these are the columns that we want to select. Now let's look at what we have on mpg4 dot okay. So we got a data frame with all the rows, but we are printing only 5 of them here, and what we have selected is column year, cylinder, and class. Okay, so this is how we can select rows, select columns using their indexes, select columns using their names, column names. Okay, fine. Any questions so far? Good. If we want to create a new column, let's say we want to create a new column on mpg4. The column doesn't exist, so I am going to call it as new column is equal to, we can do this in many ways. You can apply some mathematical operations. Say for example, mpg4, and we have a column called year in it, and let's say we have another column called cylinder. Here adding them doesn't make any sense at all. I do not want to do, but just in case if we have to do that, mpg4 within quotes cyl. So this is an arithmetic operation. So using an arithmetic operation, we are creating a new column. Adding these two columns will result into this creation of a new column. It doesn't make sense to do it this way. That's okay. Now, if you look at the mpg4, it has a new column which is created by adding the year with the another value called cylinder over here. So it created a new column. Logically, it doesn't make any sense, but just for the sake of showing how to do it, we did this. I do not want this column. I want to drop it. So we can simply say mpg4 dot drop, and what column that we want to drop? We want to drop the column which is new column, and we have to mention something called access is equal to 1, because okay, mpg4 drop this column and recreate mpg4. So right now mpg4 has four columns. They are year, cylinder, class, and new column. New column I just created for the sake of showing it. It doesn't make any sense to have this. So I'm going to drop this. So I'm going to drop this new column by saying mpg4.drop axis is equal to 1. This axis is equal to 1 will tell, are we deleting a row? Are we deleting a column? If we give axis is equal to 0, that means we are trying to delete a row. It doesn't make sense. Why? New column is a column, not a row. So we should give axis is equal to 1. Maybe in some case when you want to delete a row, you can give the row number and give axis is equal to 0 over there. Okay, so this is how we can delete a column from a existing data frame. Now you may be thinking like, why do we need to do all of this? Because there are databases and SQL can do all of this stuff. Yes, I completely agree. But there are a lot more advantages of dealing with a data frame. Now, let's say I have something like my df2 dot describe. Just one single function and it has generated some output. And this output is very, very important to understand the data. Now on this my df2, we have columns like displacement, year, cylinders, city, highway. These are numerical columns. Of course, there are other columns like class, etc., which are string columns. On the numerical column, this function describe has computed these statistics. So these things that you see here are all statistics. The mean value for displacement, standard deviation, minimum, 25th percentile, 50th percentile, 75th percentile, max, all of them computed with one single step. Probably if you have to do this in other programming languages, you would have to write a whole bunch of code one by one on each of these columns. So that's how Pandas data frames makes data analysis more simpler. Now, the first step is to understand any data is by looking at the descriptive statistics. This is called as descriptive statistics, the mean, 50th percentile, minimum, max, and standard deviation. So to understand data, yes, we need to have some very basic concepts of statistics, at least to know what is mean, what is standard deviation, what is median, 50th percentile, etc. But yeah, that's where we will probably have to spend a lot more time to learn about data analysis. You mean, I'm not sure, out with square brackets may create sometimes disturbances to look back. Can we delete them when not wished? I'm not sure which line you are talking about, but if you can be specific, ma'am, I can delete that. Okay, now. Oh, you mean the output shell? Yeah, we can delete the output shell if you want to. After building the code, you can go to kernel, restart and clear output, and your code will be there intact as it is, but all the output would be cleared from the prints below those lines. Okay, fine. Now we have to jump into the data analysis. There is a lot more things in pandas you have to learn, but let's right now jump into the data analysis. For example, we have my df2 and I want to know how many different types of cars are there. So I want to know what are the different classes of cars. So to start with my data analysis, I first want to take a look at the variable class. It is a character data. So I want to summarize this. Remember, in this data, we have 234 cars. Out of the 234 cars we have, 62 of them are SUV types, 47 of them are compact, mid-size 41, subcompact 35. So this total sum boils down to 234. Okay, now I know in my data, I have a lot of cars which are SUV types, and I have very few cars which are of two-seater types. So this is the distribution. So this is how you start to analyze the data. For numeric data, you look at the summary statistics. Look at the city mileage. So CTY stands for city mileage. The minimum mileage of a car starts at 9, and the maximum mileage goes all the way up to 35. And by the way, the units are miles per gallon. In India, we measure it in kilometers per liter, but here the units are very different. A gallon is 3.5 liters and a mile is 1.6 kilometers. So the car's mileage minimum starts with, the car with minimum mileage starts with 9 miles per gallon, and the car with the maximum mileage is at 35. The mean, most of the cars, the midpoint of the mileage is somewhere around 16. The median, 50th percentile, is somewhat around 17. So in the city, this is how the mileages look like. And in the highway, minimum mileage starts with 12 and the maximum goes up to 44. Mean is roughly around 23 and median is roughly around 24. Okay, looks like the cars give slightly higher mileage in highway than city by just looking at these two. Now, you probably don't have to do analysis to know that, because we know about cars. Imagine if you are trying to deal with some healthcare data and you see some columns like BMI, blood pressure, etc. You are not a doctor to understand this. So looking at this data will help you to realize how is the data and how does it look like. Okay, and that's how you have to start your data analysis. Unfortunately, we are already at the top of the hour. I took a little more time because we spent some time in the introduction to Python, because I felt a lot of people haven't really gone through the basics of Python. So that's where we probably lost somewhere around 10-15 minutes. Tomorrow, we would start with data visualization. We would have spent some time in today, but unfortunately we couldn't. We would start with the data visualization, and after that we would jump on to the first algorithm, which is the linear regression. It's going to be very, very exciting tomorrow, trying to learn your first algorithm, and I'm really excited to share how a typical algorithm work like. But again, my request, please try to go through some of these basics of pandas and data analysis. Tomorrow, I would directly jump into the data visualization. If you understand those concepts clearly, then it makes my life easier to show you a couple of algorithms and how the algorithms will work. Okay, that's what exactly I told you about this particular statement here. You can pretty much compute all of this using SQL, and imagine the amount of lines of code that you have to write to generate the same output in your SQL. For mean separately, standard deviation separately, minimum separately, 25th, 50th, 70th max, and do it for each variable then you kind of repeat this procedure or create a stored procedure. That's a huge lines of code and effort from the developer. Here, a simple describe statement and then done. We are not going to stop here. We're going to see a lot more things, right? There is a lot more statistical computations that we are going to do, which is much easier when you are using data analytics tools like Python or etc. compared to the traditional data processing ones like SQL. Yeah, you get a good advantage of simplicity when we do it in Python and R. Okay, I hope I answered most of the questions that came in during the session. We can do statistical computations on numerical columns, on categorical columns, on columns which has character data. We can do counts. It's called data aggregation. Okay, so this is a character column and the data aggregation is counts. These are numeric columns and the data aggregation is through statistics. That's how you try to differentiate between them. I hope this session helped you to get started with Python, and by no means this is Python. You probably haven't seen even a minuscule 1% of what Python is and what Python is capable of. My objective of this session is to get help in starting by doing the installation of Jupyter, how to use the Jupyter, how to write simple codes in Python. It's going to be a long journey for you to get started and get comfortable using all of this in Python on your own. It definitely takes a lot of time and effort from you, but believe me, if you put that effort, it is going to be very fruitful. You would get a huge advantage by learning Python. Tomorrow we will start with data visualizations and some data processing like handling null values, etc. Yes, we will do that. We will do that anyway when we go to the algorithm. Handling missing values, handling null values is also part of our job, the data cleaning. Kiran sir, that's all I have today, and most of the questions are done.
Yes, sir. Thank you so much, sir.
No
so I request all the participants to fill the feedback that is posted in the chat box. Feedback link is posted in the chat box for day 2. You can fill it. Sir, your class was so informative.
Thank you, sir.
I'm seeing the chats and all here and as well as in the YouTube also. So okay. We got an excellent feedback, sir. See, as a head of the Department of Computer Science and Engineering, I am also new to this topic, actually, data science.
Okay.
So the way you explained and the way you showed this realistic this exam with examples, so is very nice, sir.
Thank you, sir. Thank you so much.
So again, we'll meet at the same time, sir, tomorrow.
Yes.
We'll give some more time maybe for the people to fill the feedback.
Yeah, no problem.
So here actually today overall I saw around 394 participants, sir.
Wow, that's good.
So here and YouTube.
Okay.
So one request for the participants is, so after half an hour, after 4:30, Zoom will be locked and you have to attend in the YouTube only. So continuously we are seeing some people going and coming, there will be a disturbance. So we are locking, we will be compulsorily, we'll lock that Zoom and you have to attend in YouTube only. So before 4:30 only, you have to enter into the Zoom because you have to maintain a continuity. And certificate will be given to only the registered participants who have paid the registration fee. And for CIET students, there is no registration fee. Regarding the yesterday feedback, if you are not able to give the yesterday's feedback, there is no issue in that. At least from today, you try to give the feedback. If you give the feedback for the rest of the 4 days, definitely we'll consider. No issue in that. Don't worry about yesterday's feedback. So maybe I think all of them have gave the feedback.
Your feedback will definitely help me because I'm not used to teach academicians and college students. I used to teach people who have very good experience in software engineering. They come from diverse programming backgrounds. They know a lot of stuff already. So I don't know to what extent I have to go to explain the topic so that people can understand. Probably this is a good experience for me to learn how to teach to academicians and students what level they would be comfortable in learning.
Okay. But actually, today morning also I had a word with our faculty as well as some of our students also, sir. And what they said is the session is extraordinary, and they were learning a lot.
Okay. And the next 3 days is going to be much more exciting, and you would see a lot of beautiful things. All these things are probably not directly related to data science. It's just the routine programming stuff, and you could learn about this anywhere. But the moment we get into the actual data science, like what you have seen yesterday in some of the concepts of what learning happens and how that learning is evaluated, and you do that with the help of an algorithm and how the algorithm does, knowing that science really blows out minds when you do it for the very first time. And you would realize, okay, when we were in school, we have been in college, we have been taught a lot of things like linear algebra, calculus, probability, statistics, etc. But we never realized where it is going to be used. And
Okay.
now you will realize where all those concepts are going to be put to use, right from your 6th class mathematics, ratios and proportions, to all the way your engineering 3 mathematics. Everything will be put to use.
Okay, sir. I inform the same to the students also. And thank you, sir. We have already got all the feedback.
Okay.
And thank you so much. I am ending the today's session. We'll meet tomorrow,
Okay,
sir.
Okay, sir. Fine. No problem.
Thank you. Thank you. Thank you so much. Bye.